The other thing I wanted to cover this week was to review the r2mlm package, specifically with level 1 predictors in mind. So this is going to be pretty similar to Lab 4. As we might talked about, although at the time of Lab 4, r2mlm was not available on CRAN, it is now. So you can reinstall it if you haven't already, just to get the official CRAN version. I don't think it's any different, if different at all, from the version that we have. And so here I'm just setting up our data and loading packages. Note that I am taking the cluster means of sleep and pain and centering them within cluster. I also grand mean centered sleep here, although we're going to talk about grand mean centering a bit as well. So when level 1 variables are raw scores, when they're not centered, r2mlm will only report the r squared t's. So it's only going to give us that first column, the total column. Can anyone tease out why this is? The answer is because level 1 variables are ambiguous at level 1 and level 2. So decomposing the between and within components of level 1 predictors is not something that is doable for this package. I'm not sure if it's completely undoable or if it's something the authors simply don't believe is appropriate to report, but either way, we don't get the between and within columns when we have level 1 predictors. So here we see we fit a model with the raw score of pain and a random slope for pain, and we get the R square MLM table, and we only get the total column. So in lecture, Dr. Cham mentioned that there were issues with using grand mean centered variables and R squared MLM, or r2mlm, but it actually is possible, and there are a few reasons it gets tripped up. The main one is that when you use the scale function, it adds attributes to the variable. This is an R issue, not an r2mlm issue. So what this does is it essentially stores the original mean and SD for reference along with the variable. This is a special property of data frames. They can have attributes. And the downside to these attributes is sometimes they don't play nice with other functions in R. And this happens a lot with the scale function where you'll scale a variable and then you'll try to do something with it, the new scaled version, and then you'll get some kind of error and you won't understand. A lot of times it's because it has these attributes. So to remove the attributes, we can either manually subtract the mean from the variable instead of using the scale function, or if we want to use the scale function, we have to add these square brackets on at the end, where the square brackets are always empty with a comma in the middle. So here we can see at the top, I am grand mean centering pain, and then I'm looking at the structure, and we see that at first it shows that pain is numeric, that there are 2003 observations, but it's showing that there is an extra dimension here to the variable, and that's this attribute down here. So then if I scale it with the square brackets here, we note that it doesn't retain this extra dimension, and so instead of being 1 to 2003, comma 1, it's just 1 to 2003, and the attribute's no longer there. It does the same thing here, where I just subtract the mean of pain from pain. It gives the same result as this, but this is probably a little bit more flexible if you want to do more than one variable at a time. So another thing that happens is that GMC does add the between and within columns when you use it. And when we think about this, we shouldn't probably get it. When you look at the help page for r2mlm, it says that it's supposed to only give you the between and within columns if you center your variables within a cluster. But if you grand mean center them in this way, it does give you those extra columns. And this appears to be some kind of programming bug. It may be that it's seeing that the variables are centered in some way, so it's assuming that you've centered them within cluster. So it's not actually detecting whether they're centered within cluster or grand mean centered in the way it intends to. Either way, the advice is ignore those extra columns for now. And even if you grand mean center, just focus on the total column. So here you see a grand mean centered pain, but fit the same model otherwise. So this should still be an equivalent model. The only difference should be that the intercept is different, and because it has random slopes, the actual model specification will be slightly different. But either way, just focus on the total column in this model and ignore the within and between columns. So for center within cluster models, this is where you get the within and between. You'll also get within and between when you only have level 2 predictors, but in that case, you just ignore the within column anyway. That's just so you can look at the between part of the denominator, which is sensible to do with level 2 variables. But here we're looking at center within cluster models with level 1 variables. And we're going to look at two of the models you looked at in lecture, one with sleep and the contextual effect of sleep, and then one with pain and the contextual effect of pain. Or one with both sleep and pain, sorry. So here I just fit the model with sleep alone. And again, I can get the full table. So here is the first example we've seen where each column has some relevant information in it. The total is the total that we've talked about. So we have the total level 1 predictors, the total level 2, the total level 1 fixed effects, the total level 2 fixed effects. V is for the random slopes. M is for the random intercepts. F is for the total fixed effects. FV is total fixed effects plus random slopes. And FVM is fixed effects, random intercepts, and random slopes. And then you can take them out of the total with this first column, or just within, which is only sensible for random slopes or for level 1. And then you could take between, which is only sensible for level 2 or for random intercepts. And then here we just fit a model that has these extra predictors for pain in addition to sleep. And this is the same thing. We get a table of the same structure, so I won't talk too much detail about it. The one last thing we can do is check delta r squared, which is the r square change. So in here we fit a model with sleep and then a model with sleep and pain. So when we compare these two models, we are checking the relevance of pain above and beyond sleep, or the r squared of pain above and beyond sleep, and this is the result we get. So just as a practical note, in all of these slides, you'll note that I've saved an r2mlm object and then used the $ operator to extract the table I want, and I use r markdown to suppress the automatic plot it generates. This is really just something that I did to make the slides more readable. When you're doing this on your own, you can do it however you want. You don't have to save the r2mlm as a separate object or extract the table the way I did, and I'll give you an example. So here you see I have saved the r2mlm as a separate object, and then I extract the r square table. You can just run this bit of code, and then it'll give you an extra table with the decompositions that's not that important for our purposes, as well as the plot that we've seen a few times.